Hello, everybody. Very important lesson today. This is really just building and building. Today, I can prove a parallelogram using one of the 5 ways to prove a parallelogram. And this is the mini proofs version of this lesson. This will build into the full lesson when we incorporate other things as well. You need to know your 5 ways to prove a parallelogram. We've spoke about these. You need to know them, period. If you don't, you're not going to be able to do this. 2 pairs of opposite sides are congruent. That's probably the most common one, along with 1 pair of opposite sides congruent and parallel. 2 pairs of opposite sides are parallel. And then the ones that don't come up as much are 2 pairs of opposite angles are congruent and diagonals bisect each other. Those don't come up as much in this context, but um, you're still responsible for it. Basically, once you have one of these 5 pictures, you can say it's a parallelogram. A parallelogram has whichever one of these you did. So again, these are just mini proofs. Well, first we have a little bit of multiple choice. We'll just take a look at one of these. This is kind of a commonly asked question on its own. I'm going to go through each choice, and I'm going to see which one is one of those 5 pictures. It says which one is not enough, so I'm going to go through and see which one's not one of those 5 pictures. So AB is congruent to CD. AB is parallel to DC. Is that one of my 5 pictures? Yes, that's 1 pair of opposite sides congruent and parallel, so that does prove it. So now let's take a look at the next choice. AB is congruent to CD. BC is congruent to DA. Is that one of my 5 pictures? Yes, that is 2 pairs of opposite sides are congruent, so that does prove it. Choice 3, AB is congruent to CD. BC is parallel to AD. Is that one of my 5 pictures? No. If it's 1 pair parallel, the other pair congruent, that does not prove a parallelogram. That is actually an isosceles trapezoid. And that's the most common, like, non-answer. It's not a parallelogram. And finally, if I take a look at choice 4, AB is parallel to DC, BC is parallel to DA. Is that one of my 5 ways to prove a parallelogram? Yes, that is 2 pairs of opposite sides parallel. So for these multiple choice questions, you're basically just going through each choice, and if it's one of these 5, then yes, it proves it's a parallelogram, and if it's not, then it's not. And again, the most common wrong answer is the 1 pair of opposite sides parallel and the other pair congruent. If it's 1 pair that's both, then that's okay. But 1 pair that's parallel, the other pair is congruent is not a parallelogram. All right, so let's go into the actual mini proofs now. Statements, reasons. SA is congruent to BR. AB is congruent to SR. Given. Do I have one of my 5 pictures? Yes, I do. I have 2 pairs of opposite sides congruent. Once I have one of my 5 pictures, I can state that SABR is a parallelogram, and the reason is a parallelogram has, and it's whichever of the 5 things that I did. Well, which picture do I have? I have 2 pairs of opposite sides are congruent, so a parallelogram has 2 pairs of opposite sides congruent. If I did 2 pairs of opposite sides parallel, then I'd say 2 pairs of opposite sides parallel. If I did diagonals bisect each other, then I would say because a parallelogram has diagonals that bisect each other. Whichever thing I mark, that's what I put in my reason. The parallelogram has 2 pairs of opposite sides congruent. That's the gist of this. I'll do this one quick. SA is parallel to BR. AB is parallel to SR. Statements, reasons. SA is parallel to BR. AB is parallel to SR. given. Do I have one of my 5 pictures? Yes. Once I have one of my 5 pictures, I can state that SABR is a parallelogram. A parallelogram has. Well, what did I prove? I proved 2 pairs of opposite sides parallel. So I'm not going to do all 5 different pictures. I think at this point you get the gist. Once I have one of those 5 pictures, I can state that it's a parallelogram. And the reason is a parallelogram has whichever one of those 5 things you proved. One more thing I do want to do, though, and that is number 9. There is, I mean, I'll still call this a mini proof, but there's really, there is one additional step to this, which we already talked about in one of the mini proofs lessons that we've been doing. Statements, reasons. AB is congruent to CD, given AB, CD. So I have one pair of opposite sides congruent. I either need the second pair of opposite sides congruent or those parallel. It gives me that angle 1 is congruent to angle 2. Well, when they give you that angles are congruent, you need to look to see if they're alternate interior angles. Yes, they are alternate interior angles. So carve out your angles. So we see our Z. And once you carve out your angles so that you see your Z, we see our parallel lines. So if they give you alternate interior angles, you need to conclude that they're parallel. So now I can state that DC is parallel to BA. Parallel lines cut by a transversal create congruent alternate interior angles. We already did a mini proof lesson on this. Now, do I have one of my 5 pictures? Yes. I have one pair of opposite sides congruent in parallel. So now I can state that ABCD is a parallelogram. The reason always starts with a parallelogram has. Well, what did I prove? I proved that it has one pair of opposite sides, both congruent and parallel. A parallelogram has one pair of opposite sides, congruent and parallel. That's how I prove parallelograms. There's going to be more to this as we get to the real proofs. But once I have one of these 5 pictures, I know it's got messy. Once I have one of these 5 pictures, I can state that it's a parallelogram because a parallelogram has that, or that, depending on what I proved. And the most common is this. I'd probably say this and this are the 2 most common. That's it. Practice it. Once you get it, you can move on to the next level. If you can't do this, you can't move on to the next level. So, you know what you got to do. Goodbye. Goodbye.